Okay, so today we are discussing the daily question of LeetCode, which is minimum number of moves to seat everyone, right? So there are n seats and n students in a room. You are given an array of seats of length n, where seats of I is position of ith seat, and you're also given the array of students of length n, where students of j is position of jth student, right? So we have some seats, we have some position of seats, and we have some students, we have some position of students, right? Both given in separate vectors. uh, you may perform the following move in number of times. Increase or decrease the position of ith student by 1. Right, from we can move either move the student plus 1 or minus 1 its position, and we have to return the minimum number of moves required to move each student to seat such that no two students are in same seat, right? Note that there may be multiple seats of students in same position at the beginning. So essentially what question says is, let's I'll explain the question properly. What the question says is, we have some seats, right? uh, we have some seats position given to us, and we have some students position given to us, right? It has something like this, and this is 5, this should be also 5 equal, right? So what we have to do is assign each student some seat, so that our the student should move minimum number of moves. Moves is defined as plus minus 1, plus 1 or minus 1 from student's position, from student's position. So what we have to do is, let's take an example to make it more clear. We have seats and students like this, right? So let's take this example, right? So we have seats like this. Let's have the seats. We have a seat at position 1, we have a seat at position 3, and we have a seat at position 5, right? And we have students something like this. A student at position 2, let's have this with different color, I guess. We have a student at position 2, position 7, and position 4, right? So the question is asking us, what we have to do essentially is place a student to some seat, right? Place a student to some seat. This is what we are doing. So to do this, what we need is some minimum number of moves. Like if this is moving here, this is moving here, something like this. It has to move. If 2 is moving to 1, it has to move by 1 position. If 4 is moving to 3, it has to move by 1 position. 7 is moving to 5, it has to move by 2 positions, right? So we have to basically minimize the number of moves. We have moves as plus 1 and plus 2 for this, right? It is just an arbitrary example. So to minimize this, what we would do is use a greedy approach. What is a greedy approach here? Greedy approach is basically, we are using greedy approach here. Greedy approach is basically using local minimas to get to hope getting a global minima, right? So for example, for student 2, it is feasible for me to move to seat 1, right? Because I have to only move once. I can move to seat 3 also, but let's just assume we are moving to seat 1 right here. And for 4, if I need the closest seat to 4 is 3, right? So I need plus 1 move, and the closest seat to 7 is 5, right? So it would take 2. Now let's say, and how we are doing this is, we are just sorting our seats array, and we are sorting our students array, so that we get some sequence like this. And what I am saying is, give the closest seat to closest student, closest seat to closest student, so and so forth, expecting to get the minimum distance. And why this approach works, right? Why this works is wait a second. Okay, if we are saying uh right, okay, wait. If I, by this approach I can say that I'm assigning the student to nearest seat, right? So assignment would look something like this, right? This student will be assigned to this seat, this student will be assigned to this seat, and this student will be assigned to this seat. This case is after sorting. By our approach this should be the case, and I am assuming that this is the minimum distance. To prove it, the contradictory case would be something like this, right? Let's say this is here, and we have some cross assignment like this. uh, yeah, let's rough it. We have some cross assignment which would look something like this. The 4 is going to this seat 5, and 7 is going to see this seat 3, right? This is the contradictory case. I have a formal proof of this. Basically what I'm saying is, when we have this type of assignment, this is generally not optimal, because the cross assignment is not optimal. This has a formal proof. I have tried to prove it. This would be a bit of casework, but if you want to see the proof, you can see this part of video, and I will give some resource for the proof also. You can search for it, but I will just give the glimpse of the proof. Basically, if we are doing this, just take this example only. Here moves will be 1. Here the moves required, this for 4 would be 1, but for 7 it would be 7 minus 3, that is 4, right? So total moves here would be 4 plus, this would be 4 plus 1 plus 1, that is equal to 6. And earlier we were able to get by the normal assignment 1 1 and 2, which is 5. So 5 is better than 6, right? We need lesser number of moves. So to if you are not interested in proof, you can just look at the code. The approach of this question is basically sort both the arrays, and just assign the closest seat to closest student to closest seat, right? We are assigning it like this, and here we have seen from example that the cross assignment like this, if we are not assigning the closest student to closest seat, it would look something like this, right? We are not doing this, then it would look something like this, right? The cross assignment, and the cross assignment would always give us in greater distance. The cross assignment would give us greater distance. And the proof for this, I have prepared a proof for this. You can just go through it. Basically it would take some cases. If normal assignment looks something like this and cross assignment like this, and you can go through the proof if you want. Pause and go through the proof. I have just prepared it on my own. So I have just prepared it for 2 cases, but it could be it is for 6 cases, so you can do it on your own. And just I'll go through this. This is the proof of the cross assignment. You can search it on net, or you can just go through my notes only. So the point is that a normal assignment would give you the lesser distance than cross assignment. This can be proved using this approach. This is very simple proof. You can just go through it, right? And yeah, let's just code the question then. What our approach was just to sort both of the arrays. Sort seats dot begin, comma seats dot end, and similarly we'll sort students dot end. And now what I'm doing is having a int moves equal to 0 for int I equal to 0, I less than seeds dot size I plus plus, and moves would be basically plus equal to absolute of seats of I minus of students of I, right? And we would just return moves. This is normal assignment. We are just assigning, by this we are just assigning the minimum, the closest seat to closest student, and this greedy approach works. You can go through the proof if you want, but yeah, let's just test the code. So yeah, let's just submit it. It has got accepted. And to be honest, I don't trust this runtime. This is very inconsistent. I'll just show you an example. Like I'm getting a 0 millisecond runtime. This is, by the way, this is O of n time complexity and O of 1 space complexity. So just for showing that, don't trust this runtime. As now, let's see if I resubmit the code, what would happen. It might change the runtime. It is not a consistent factor to judge the code. So let's just see. I have not changed the code anything, and I have got a 9 millisecond runtime. As you can see, the code is same, right? And if I run it again, I would get a different runtime again. So it is inconsistent. As you can see, it is now I'm getting a 4 milliseconds. So do not trust this runtime. Anyways, so that's it. Thank you for watching.